This is background to the geology and the tectonics of the tragic earthquake that happened on the 28th of March 2025 in Myanmar. I'm not going to talk about any of the human side of things, buildings or any of that. This is just about the geology and about the tectonics for context. Okay, and I'm recording this on the 30th of March, so 2 days after the main event. Okay, so if we look at the USGS catalogue of latest earthquakes, this is Mandalay, the nearest large city to the main earthquake. All of the circles in brown here are ones that happened within a day of the main earthquake, and all of these ones in yellow happened in the previous week or so. Okay, the size of the circles correspond to the magnitude of the earthquake, and the most recent ones are plotted on top. Okay, so this was taken on the 29th, so a day after the earthquake. Okay, so the largest one, the magnitude 7.7, is sitting here underneath everything, and then all of these in brown are aftershocks. There was very rapidly a magnitude 6.7, which is this one just to the south of it, and then these aftershocks are sitting basically along a north-south line that runs through the central axis of Myanmar. The USGS only plot teleseismic global earthquakes magnitude 4.5 or larger. If we look at the moment magnitude solution, the moment tensor solution, I've discussed what these mean and how they're derived in my video about Santorini, so have a look at that if you don't understand what this is. But essentially, this tells us about the motion, the sense of motion on the earthquake. So in this case, the two conjugate planes are aligned with their common axis, pretty much vertical. So that means that the motion has to be in horizontal, either along a fault in this direction or along a fault in this direction, the two conjugate planes. The blue areas are where the first arrivals, the first P-wave arrivals, would be in a compressive direction, and the white areas are where the first P-wave arrivals would be in a dilation, a sense of dilation. Okay, so you can produce this by a fault which is oriented north-south with motion on the east block of it to the south and on the west block of it to the north. And that's consistent with this north-south orientation running through here. Okay. The red lines here are the plate boundaries. So we have the Indian plate, the Eurasian plate, and then there are some other plates in here which are marked at this large scale. We're going to have a look at the plates now and their plate motions. So this is the Indian plate with that boundary that was marked on the USGS map. We have the Eurasian plate up here to the north, and then the small plate, the Sunda plate, the Burma plate down here, and the Australasian plate. And these arrows with numbers, these are the directions and speeds of plate motion, of relative plate motion. Okay, so you can see, and in this drawing here, this is relative to the Eurasian plate. Okay, so you can see that India is moving northwards at up to about 35 to 40 millimeters per year into Eurasia. Okay. Things out here to the east are moving south and southeast at 15, 11 millimeters per year, and then this very small Burma plate is actually moving northwards at a very fast rate of 46 millimeters a year. So it looks as though India is busy pushing into Eurasia, and these things are sliding out of the way to get out of the way of India. 45 million years ago, India was much further south, down here, and between India and Eurasia there was an ocean the Tethyan Ocean, the Tethys Ocean, and that started to subduct along the southern Eurasian boundary. So it was subducting northwards, and that dragged India and Africa northwards. And in fact, it was the collision of India and Africa with the Eurasian plate as the Tethyan Ocean finally closed and was completely subducted. That's what's produced the Himalayas and the Alpine Himalaya orogeny mountain building event. India is still moving northwards because although it's being dragged underneath Eurasia, it's still connected at depth to the Tethyan plate, which is sinking into the mantle and dragging India northwards. So that's why there's still this motion. You can see India has moved quite a way into Eurasia. In fact, we can see that if we look at the Himalayas, a map of the Himalayas. So this is the Himalayas, and this is their southern boundary here. Okay, we can see it approximately follows the Indian plate boundary. The Indian plate boundary comes up here, runs along here, and then tightly folds back in through there. Okay, so it's pretty close. You can see basically the Himalayas run approximately east-west. There being north-south compression, this east-west range. But you can see down on the eastern side, they're flowing out as well. Everything is moving out of the way to the south and the east. So you've got this high ground here where the Himalayas actually turn around as India is pushing into them. So this is one of Tectonic's seminal experiments. So this is plasticine, and he's pushed a steel block into the plasticine. It had a free surface on its right-hand side, and what you can see is that the plasticine has moved out of the way of the steel block. There's not a lot of topography, so we haven't built mountains here. What's happened instead is there's horizontal motion along these faults. They're very localized shear zones in the plasticine where all the motion is horizontal. So these are called strike-slip faults, and that's what we saw in the Myanmar earthquake. So it's one of these faults that would have been down here. The complex geometry that we see here at that surface of the plasticine, that outer edge of the plasticine, is analogous to the complex geometry that you see in the China Sea with China and Thailand and all of those, Myanmar and all of those countries that are pushing out into the China Sea. So this is once again the plate boundaries, but also some of the major strike-slip faults of the horizontal stress relief faults. So India is moving northwards at 40 millimeters a year or so. This block here in China, the southern China block, is moving eastwards and southwards at 15 millimeters a year. The Cambodia-Vietnam block is moving more southerly at 11 millimeters a year. And in fact, this block here, the Burmese block, the Burmese plate, is moving northwards. That's the bit that's moving northwards at 46 millimeters a year. So we've got over 50 millimeters a year relative motion between this western Burmese block and this eastern Cambodian block. And that's all taken up along this major strike-slip fault. And in fact, this strike-slip fault here through the middle of Myanmar is the fault that takes up most of the relative motion between India and Eurasia. So this is where the earthquake happened. Well, why did it happen here rather than anywhere else on the fault? Well, to look at that, we have to look at the historical earthquakes. And this is a map from ReliefWeb as of February 2025, so very up to date, showing historical seismicity in Myanmar. It's color-coded and size-coded by magnitude. So magnitude 7 to 8.6 are the largest red circles. This black line is that fault that I showed you, running through like this, that strike-slip fault. And you can see along here, or very close to here, we have 1931, magnitude 7.58, 1946, magnitude 7.64, 1941 magnitude 7.52, and then the extension of this up to the north, 1950 magnitude 8.6. So these are relatively closely spaced here, here, and here, about 200 kilometres distance between them, 200 to 300 kilometres. And then there's a gap of 500 or 600 kilometres, and then we have another one down here. And what happens when you have large earthquakes on a fault? That region of the fault which has ruptured is no longer supporting the stress because it's been relieved. That's what's happened with that fault motion. And so we have this region here to the north of Mandalay. The stress has been relieved on these faults, on this fault by these earthquakes. Down here to the south of Mandalay, the stress has been relieved on with a magnitude 7.52. Then the rupture size is probably going to be about 100 to 150 kilometres long. So we've relieved the stress on a region like this, on a region like this, and on a region like this. So that means that the only bit of the fault which is now supporting the stress is this bit between here and here, pretty much centred around Mandalay. And so the earthquake that happened on Friday, basically it is the final rupturing of this region here. There might be possibility for another one further south at some point. You can see that every few decades there's something large along this fault, but I'm not qualified to say whether or not that's the case. Okay. So if we now look at the fault moment magnitude solution, it sits like this, and you can see this plane here is very consistent with the orientation of the fault, and it's consistent with this movement of the eastern block to the south and the western block to the north. So this is the solution. Okay. So that's a very brief tectonic background to the tragic events that happened 2 days ago.